How's everyone doing out there? Algebra 1ers in particular, I see you. Checking out 5.5, keeping it moving in Chapter 5, dealing with linear equations, which are, straight lines. Some go up and to the right, some go down and to the right. Some are rather boring and flat, like the Midwest, no hills there. Some go straight up and down. Spider-Man could walk up these or crawl up these. I haven't seen any of the newer Spider-Mans, but I'm assuming he could still walk and run up these. So, new way that we can graph out these types of linear functions dealing with standard form looks kind of like the alphabet, because we see A, we see B, we see C. We'll soon see that in Chapter 6 this comes back a little bit more, but the main use of this form, because we've seen slope-intercept form, our buddy, y equals mx plus b. That was cool. That was the first one we learned back in 5.2. Or no, sorry, 5.3. In 5.4, we saw point slope form, which was cool, a little bit more complex, which allowed us to graph a line just given one point and given the slope, and also create an equation based off of it. The main use with standard form is that this helps us allow us to find intercepts, both x and y. The steps seen here, as far as a quick graph, will allow us to do that. Plugging in 0 for x, that will allow us to find the y-intercept. We'll write that as 0, comma, that number. Plug 0 in for y, and we'll find the x-intercept. So kind of vice versa. Notice that if we plug in for x, this gives us our y-intercept. If we plug in for y, this gives us our x-intercept. We'll then plot the two values and graph that thing out. But first, let's see what this algebra is like before we start graphing. So determine the x and the y-intercept for the following equations. Let's go with the steps, although we can kind of swap these out as we see fit. But we'll first plug in for 0 on x. So this will allow us to get the y-intercept. So if x is 0, it looks like this. What's this product going to give us here, 4 times 0? It should be saying 0. So really, it's 0 plus 3y equals 12, which is really just 3y equals 12. So based off of dividing, y equals 4. So this allows us to say that our y-intercept is going to be when x was 0, y was 4. So if we're going for the x-intercept, the x-intercept has us plugging in for y. So we have 4x plus 3 times 0 equals 12. So really just 4x equals 12. This says that our x-intercept is going to be 3. So 3 comma 0 is our x-intercept. And our y-intercept was 0, 4. Check that out. I'll give you a moment to try the next one. But you should be saying that for our y-intercept, if x is 0, y is going to have to be positive 3. And the x-intercept will occur if you have 2x minus 6 times 0 equal to negative 18. So pretty much 2x equals negative 18. Dividing by 2 on both sides, we'll say that x equals negative 9. So in reality, our x-intercept is going to be negative 9 comma 0. Check that out. Look at you, Algebra 1 student, just killing it on whatever day this is. So keep it going. Try the next one. You're capable. You're a smart person. Your y-intercept for this will occur if x is 0, so pretty much 4 times 0 minus 5y equals 16. That doesn't deter you though, just leaves you with negative 5y equals 16. You can take this further, dividing by negative 5. So this is going to say that y equals negative 16/5. So your y-intercept in this case is 0, comma, negative 16/5. There you go. How about that x-intercept? Let's get it. Pretty much all of the arithmetic is going to say 4x equals 16. So x is going to have to be equal to 4. So your x-intercept collectively is going to be 4, comma 0. And you're done. Now let's graph these out. So the same kind of song and dance that we've been doing for the y-intercepts. Let's plug in when x is 0. This leaves us with 3y equals 12. So y is going to be 4. So this is going to say that our y-intercept is going to be 0, 4. Don't get too antsy. Don't graph these out just yet. Let's make sure that we really focus on the algebra as far as solving these equations. We have 2x plus 3 times 0 equals 12. You're crafty, so you're just going to jump ahead and say 2x equals 12. X is going to be equal to 6. So our x-intercept is 6, comma 0. So let's graph these out now that we have 2 points, 0, 4, 6, 0. As we can see, we don't even need the slope to graph this out, which is kind of cool. We're totally capable. We could totally find it. But as far as just having to graph this out, we did just that. I'll give you a moment for the next one. Try it out. You have 4x minus 5y equals negative 20. Pause the video, give it a shot, see what's going on with it. But collectively, you'll be saying that when x is 0, the y term is going to be 4. When y is 0, x is going to be negative 5. So you see here, this is your y-intercept. This is your x-intercept. So let's plot them out. 0, 4. Y-intercept's negative 5, so let's take that to the left. We see that this slope's positive, which is pretty cool. We could also plot some more points out if you want to. So our change in x is 5, change in y is 4. So this would be over 5 and then up 4. This part's bonus getting these other points on here, but you know slope, so you're totally capable of doing this. Back 5 over 4. Sorry, back 5 down 4. Already looks pretty linear. Looks as if these are all going to hit. And so I hope that you're all starting to see the correlation between using slope and using these equations. Being able to really feel comfortable using slope will make graphing a lot easier. You can get extra points. You can wow your friends without having to plug in for a bunch of arithmetic. So we also had the 0.58. We also had negative 10, negative 4. But we still fulfilled what they were asking, getting the x-intercept and the y-intercept. So standard form is pretty cool. It's convenient, allows you to graph, just a little less time consuming with the arithmetic. If you have any questions, email me or ask in class. Thanks for watching. Make sure to subscribe below.